Hey guys, welcome to today's video. Today we are going to talk about coordinate system in engineering diagrams. So the contents of today's video are the introduction, what is a coordinate system, the types of coordinate system, first angle projection method, third angle projection method, the comparison between first angle and third angle projection system, the advantages and disadvantages, the applications. Today, we will explore the importance of this system in the field of engineering and how it has revolutionized the way we design and manufacture machines and structures. Engineering drawing is a crucial aspect of any engineering project, and the coordinate system plays a vital role in ensuring accuracy and precision in measurements. By dividing the drawing into four quadrants, this system provides a clear and concise reference point for engineers to work from. This helps to reduce errors and inconsistencies in the design process, ultimately resulting in better quality products. So let's dive in further and explore the fascinating topic. What is a coordinate system? A coordinate system is a method used in engineering drawing to represent three-dimensional objects on a two-dimensional surface, which divides the object into four quadrants and projecting each quadrant onto a plane, which also allows engineers to accurately represent the object's size, shape, and position. Used extensively in mechanical and architectural drafting, particularly useful for creating detailed drawings of complex machinery and structures. By using visual aids such as diagrams and 3D models, engineers can easily understand how different parts of the object fit together and interact with each other. There are two types of coordinate systems. The first one is the first angle projection method. It is a technique used in engineering drawing to represent three-dimensional objects on a two-dimensional surface. This was developed in Europe in the 19th century and is still being widely used today. One of the advantages of the first angle projection method is that it closely mimics of how the human eye sees object in real life, which makes it easier for engineers to visualize how the object will look in reality. However, one disadvantage of this method is that it can be confusing for those who are not familiar with it. It requires a high level of knowledge and skill to use effectively. The second the second one is the third angle projection method. The third angle projection method is a technique used in engineering drawing to create two-dimensional representation of a three-dimensional object. It was first introduced in the United States century in the early 20th century and has since become the standard method for creating engineering drawings. One of the advantages of the third angle projection method is that it provides a clear and accurate representation of the object being drawn. This is because of the projection lines are being drawn from the object to the observer, which creates a more realistic image. However, one disadvantage of the method is that it can be more complex than other methods such as the first angle projection method. Comparison between first angle and third angle projection methods. As you can see the diagram, it shows us that the first angle system is being used in European countries and also for the ISO standard, in which the planes are opaque, whereas the third angle system is being used in USA, Japan, and Thailand, in which the planes are transparent. First angle projection method. One of the most popular ways to acquire engineering drawings, mostly for orthographic projections, is using this method. Orthographic projection is a graphic technique for converting three-dimensional objects or buildings into various views or perspective projection. The top view, front view, and the side view make up the orthographic view most frequently. One technique for sketching orthographic projections is the first angle projection, which is accepted everywhere else but in the United States. The object is positioned in the first quadrant in front of the vertical plane and above the horizontal plane using this projection technique. The characteristics of first angle projection method in engineering drawings. Typically used in Europe, Asia, India, and Canada. The object is positioned in the first quadrant. The object is positioned between the projection plane and the observer. The plane of projection is opaque. The top of the horizontal axis represents the front perspective. The top view is at the base of the horizontal axis. Right view is on the vertical axis left side. Left view is on the right side of the vertical axis. Third angle projection method. A sequence of two-dimensional perspectives is employed in this perspective projection technique to depict three-dimensional objects. The 3D object to be projected is positioned in the third quadrant behind the vertical plane and below the horizontal plane and is positioned in third angle projection. The projection planes in third angle projection are transparent as opposed to the first angle projection when they are supposed to be opaque. Japan requires the use of a third angle projection schema for industrial designs for product manufacture, and the United States is the primary country that employs this projection technique. Characteristics of third angle projection in engineering drawings. Typically used in the US and Australia, the object is positioned in the third quadrant. The projection plane is positioned between the object and the observer. The plane of projection is transparent. The bottom of the horizontal axis represents the front perspective. The top view is at the top of the horizontal axis. Right view is on the vertical axis side. Left view is at the left side of the vertical axis. Advantages and disadvantages of the coordinate system. One of the main advantages of using the coordinate system in engineering drawing is its ability to provide accurate and consistent measurements. It is because of the use of the coordinate system uses a standardized set of rules and conventions that ensure all drawings are made to the same specifications, which makes it much easier for engineers to communicate their ideas and design to others as everyone is working from the same basis. Another advantage of the coordinate system is that it allows for greater precision and detail in drawings by breaking down complex shapes into smaller, more manageable parts. The coordinate system makes it possible to create high detailed and intricate designs that would be difficult or impossible to achieve using other methods. The disadvantages. One of the main disadvantages of using the coordinate system in engineering drawing is its complexity. The coordinate system requires specialized knowledge and training to use effectively, which can be time consuming and expensive to acquire. This can be a barrier for those who are new to the field or do not have access to the necessary resources. Another disadvantage of the coordinate system is that it can be difficult to visualize and understand without the aid of diagrams and examples. The system involves projecting a three-dimensional object onto a two-dimensional surface, which can be challenging to conceptualize. This can lead to errors and inaccurate in the final project if not done correctly. And now, on to the last part, the applications. The coordinate system is an essential tool in engineering drawing with a wide range of applications in the design and manufacturing of machines and structures. One of the primary uses of the coordinate system is in the creation of technical drawings that accurately represent the dimensions of a particular object or structure. This is particularly important in fields such as architecture and mechanical engineering, where precise inch measurements are critical to ensuring the safety and functionality of a design. Another key application of the coordinate system is in the creation of assembly drawings, which provide a detailed overview of how different parts fit together to form a larger structure. This can be useful in a variety of industries, from automotive manufacturing to aerospace engineering, where complex systems must be designed and assembled with precision. By using the coordinate system to create these drawings, engineers can ensure that all components are aligned correctly and that there are no gaps or misalignments that could compromise the integrity of the final product. So guys, that brings us to the end of the video. Please do share a like and subscribe for more videos to come. Thank you.